Hello, and welcome back to sections 6.4 through 6.5. In this video, we'll be going over example 1. We'll be applying method of sections to the truss you see here on the screen. We've been asked to find the internal force for members LK right here, KC right here, and CD right here. So, to do that, let's switch over to our visualizer. Alright, so I've redrawn the problem here. So we want to cut this member, because that's how we're going to find these forces. And so when you make your cuts, generally what I'll do is I will mark the members that I want to cut. So I want to cut LK, so I'm going to make a cut here. I'm going to cut CK, so that's right here. And I'm also going to cut CD, which is right here. And then what you're trying to do is you're trying to cut all the way through this so that you can have two different rigid bodies. So to do that, we can create this cut. And I guess here I'll round that off a little bit better. So we have this cut right here. And so now I'll have a right-hand side and a left-hand side. So what I would advise doing is redrawing both sides of this. And so it should look something like this when you're done. Sorry about the freezing there. Alright, so we have everything on the screen, I think. Just about. A little bit off. But we have the new members. So we have the green one, which was the left-hand side over here. Same external forces, AX, AY, 20,000 newtons, 30,000 newtons. On the right-hand side, so the orange diagram, we still have the 40,000 and the GY. There we go. And then the new forces are these internal forces. So the tension from L to K, again, this is equal but opposite. So when I put this back together, this goes away. This is tension C to D, C to D. Now this is the same as when we did method of joints. Outward arrows mean tension, inward arrows mean compression. Same reasoning too. And then up and down, so on these two diagrams, that's going to be the tension from C to K. And again, these are going to be equal and opposite. So I have created 3 unknowns. So if I go and I start counting unknowns on my diagrams, on this diagram over here, the green one, I have 1, 2, 3, 4, 5. There are 5 unknowns here. You can't see that. All right, there you go. On our orange diagram, we have 1, 2, 3, 4. 4 unknowns. That means if I want to solve for these external forces, I want to use the right-hand side. And sorry about it freezing. I'm not sure why the screen is freezing so much. So we're going to get 3 equations to solve for this right-hand side. We're going to get sum of forces in the x, sum of forces in the y, and sum of moments. We can also do variance where we don't use it. So we don't need to find gy. And we can actually solve for tension CD, tension CK, and tension LK without ever finding gy. So basically, the force gy, or the normal force at g in the y direction, this is in the y, so I can't ever do sum of forces in the y on this orange diagram. If I do, I'll introduce this unknown. I can do forces in the x, I can do sum of moments about g, and then if you wanted to avoid using gy, you'd have to do another moment equation, and the moment equation would have to be along this line of action, so you would dash this up, and it would be right here. As you would do a moment about this point, you would make up a point here. Because you know where it is. You know it's up 3 and over 2. So if you wanted to do it without finding gy, that's how you would do it. So we'll do the first 2 pieces, and I'll show you, and then we'll go ahead and find gy anyway, just because that's generally, it's more work, but it's probably easier for you guys to see. So let's start off. I'm going to zoom out now. Alright. So we're going to use the orange diagram. So I'm going to call that diagram 1 for right now. Okay. So we're using diagram 1. it's good to let the person like me, that's grading this, know which diagram you're using. So in diagram 1, so again, we don't want to use gy if we can avoid it, so let's do a sum of forces in the x. Actually, let's do a sum of moments about x first. Sum of moments about g. There we go, that's the correct thing to say. Equal to 0. So what this will do is this will give us tensions only, and gy won't show up in there because we're doing it about g. So I'm going to assume right-hand rule positive. So my moments are going to be created by this 40,000, tension LK, tension CK. Tension CD, if you notice, the line of action goes through G, so it will not show up in the problem. So we're only going to have 3 things in here. So let's just work our way down here. So tension LK. So note that on the orange diagram it's drawn to the left. It is going to act 3 feet above. So tension LK times 3. And then determine your sense manually, just like we did with other moments back in, I think, chapter 4. So this is going to rotate this way around, which is positive, so we're going to leave it alone. We have tension CK. It is going to act, so we have 2, 4, 6, and there's another 2 here that I should probably draw. So 8 total meters away. And that is going to create a positive moment. And then we're going to do the 40,000. So plus 40K. That's going to act 2, 4, 6 away. And that'll all be equal to 0. So gy doesn't show up, but this is equation. So this is equation 1. So we're going to get a system of equations right now. Eventually we won't. So let's do a sum of forces in the x, because that doesn't include gy. I'm going to assume right is positive. So when I do that, again, gy isn't in the x, so it won't show up. This is in the y, it won't show up. So we'll get tension CD and tension LK. So negative tension LK, negative tension CD equal to 0. So this is equation 2. So I have all of my unknowns in these 2 equations. LK's in both, CD's in this one, CK's in that one. So I need a third equation to solve for 3 unknowns. And so like I said, you could do a moment about this point, and that would be your third equation if you don't want to find gy. But we'll find gy real quick, and we can do it the long way around this time. Alright, so let's go ahead and finish with diagram 1 so I can show you what happens with diagram 2. So this would then be sum of forces in the y. Again, if you don't want to do 4 equations, just do a moment about this point up here. Sum of forces in y equals 0. So that's going to be, gy is going to be introduced into this. We're going to get minus 40k. This won't show up, this won't show up, and we'll get tck. So, and that's going to be minus, all equal to 0. Alright, so now I've created a fourth unknown by adding gy in. So if you do that, you'll need to go find gy, but you can't use this diagram. It's a 2D rigid body problem. We only have 3 equations that are independent. We've used 3 independent equations already. So that means if I want a 4th equation, I have to go use a different diagram. And so you could try to use this one, but gy doesn't show up over here. And it has a whole bunch of other unknowns. So instead what you want to do is you want to come back up to this original diagram. So I will call this diagram 2. And we will use this original diagram to find gy. So let's just split our thing here. So this side's going to use diagram 2. So again, you don't have to do this. You could have just solved everything by just using this point and doing a moment. But if you don't see that, I want to show you what to do on the other case. So if we want to find gy, we use the entire yellow diagram. We ignore the cut. We just treat it as a big free body diagram. We're going to do moments about a, because I never want to find ax or ay. Again, I'm going to assume right-hand rule positive. And so I'm going to have the 20k, the 30k, and the 40k, and then the gy. And so the gy will be the only unknown in this equation, and we'll be able to find it. So we'll get 20k acting 2 meters away from A. so it's 2 meters away. And that's going to create a negative moment. Actually, all of these except for GY are going to create negative moments. So manually determine the sense. So plus 30K times 2, -1 for sense, plus 40K times, sorry, that shouldn't be 2, that should be a 4, because it is 2, 4 away, and then the next one is 2, 4, 6 away. That's -1, and then we got to continue our equation. Now you're out of room. And so then we're going to get plus GY times 2, 4, 6, 8, 10, 12 away. And that's all equal to 0. So you solve this for GY. You'll find out that GY is 100K over 3, or approximately 33.33 kilonewtons. Alright, so we can then bring that back over here and we just start solving. So then we can say, oh, well, this is 100K over 3. And we can solve this for TCK. So TCK will then become so we're going to get 100, because it's minus that. So we're going to end up with a, so this is like 33, and we have a negative 40 here, so we're going to end up with a negative number. We're going to end up with negative 6.6 repeating kilonewtons for TCK. So again, that's assuming tension. So we want to note tension or compression. So we could also write this as 6.6 repeating kilonewtons in compression. But we want to use the tension one because that's what we drew in our diagram. We drew it in tension. So when I bring TCK, I can then plug it back in up here. So I'm going to put in negative 6.6 repeating, and that's kilonewtons. Make sure you bring the K with you. You're going to solve this one for TLK, and when you do that, you will find that it is also negative, and it'll be a negative 62.2 kilonewtons. Sorry, I should have carried a fourth sig fig there because we're going to use it down here. I don't have that in my answer. So that's in tension. And again, you could write this as 62.2 kilonewtons in compression if you wanted to. And then to finish up, you take that negative 62.2, you put it over here. So negative 62.2K. So you're going to have two negatives here. You're going to have negative times a negative, so it's going to become positive. So TCD will become positive 62.2. So this is 62.2 repeating. So that'll help with that. Kilonewtons in tension, because again, that's how we drew it. So there you go. So you now solve for your three internal forces. I showed you how to use an extra diagram to find one of your reaction forces, so your original reaction forces. I also showed you, if you don't want to go find these reaction forces, how you can use extra moment equations to keep your undesired variables out of your equations. So if you have any questions, feel free to contact me.